Today on Engineering Newswire, we're creating everlasting digital data storage, 3D printing a fully automated dart gun, and replicating human muscles in metal. Scientists at the University of Southampton have taken a major step forward in the development of digital data storage that is capable of surviving for billions of years. Using nanostructured glass, the scientists developed the recording and retrieval processes of five-dimensional digital data through femtosecond laser writing. Coined Superman crystals, the glass discs can reportedly store up to 360 terabytes of data per disk, have a thermal stability of up to 1,832 degrees Fahrenheit, and will last almost forever at room temperature. This means your favorite novels like 50 Shades of Grey, songs like Hanson's classic Bop, and articles like Batboy can live on in eternity. Though the Southampton team first demonstrated this Superman crystal technology in 2013, the storage capabilities were limited. To address this issue, a femtosecond laser delivers ultra-short light pulses onto a piece of quartz, creating microscopic dots. Each dot encodes 3 bits of information, including the position of the dot and the intensity of the polarization of the light in the 3 layers of the quartz. This means that a comparable CD or DVD with around 1,000 layers would have a data capacity of hundreds of terabytes compared with hundreds of megabytes for today's commercial discs. Currently, the King James Bible, the Magna Carta, and the Universal Declaration of Human Rights have all been printed in this format. We can only assume the complete adventures of Harry Potter is next on the list.
As some of you may know, the product design and development team loves testing out new toys. Should I have in the train mode or should I? So when I learned that software programmer Jesse Kovarovics had launched a Kickstarter for his FDL-1 3D printed robotic, web-enabled, high-powered, fully automatic foam dart launcher, I had to check it out. The project must reach a pledge goal of $15,000 by March 13th in order to be funded. Aside from the hardware and electronics, everything else is totally 3D printed. In fact, it can be printed on almost any consumer printer that has a minimum build size of 6 inches in each dimension. Each part is designed to be easily printed with very little support and bridging required. Plus, the FDL-1 is robotic rather than fully mechanical, so it is controlled by a particle photon microchip. It can be tweaked by the user and can perform pre-programmed commands and repetitive maneuvers. According to the Kickstarter, the FDL-1 has the fastest launch speed of any foam dart blaster on the market. The flywheel motor's speed can be adjusted on the fly, so you can tone things down or crank it up to near paintball level velocities. Perhaps coolest of all, the dart gun has Wi-Fi built directly into its microchip, which means you can control it from virtually anywhere. So if you're a tinkerer who loves robotics and 3D printing, then check out the Kickstarter today.
HRL Laboratories has discovered how to replicate the quick stiffening and softening of human muscle in metal. And someday, the technology could be used to create the ultimate automotive suspension, or to give a robot the sensitivity and strength of a human being. The researchers claim that their setup can change from stiff to soft by a factor of 100 in milliseconds, independent of the load it's carrying. This performance surpasses existing mechanisms by at least 20 times in either speed or useful stiffness change. According to the principal investigator, Christopher Churchill, the human body is home to a range of variable stiffness structures that enable efficient load bearing and nimble activity. Yet these features in the human body are rarely replicated in engineering due to the complexity, power, and cost of doing so. The traditional approach of building a soft system and then adding damping is expensive and has low bandwidth, so Churchill and his team built a still system and then softened it instead. The system is really just strips of metal that are precisely balanced in a series. This gives it huge potential in cars, trains, and robot arms. According to Churchill, quote, utilizing adaptive negative stiffness to soften stiff systems on demand has the potential to solve shock and vibration problems that only get more difficult with these next generation platforms.
Do you have story ideas? Comment below and we'll cover them in an upcoming episode. For the PD&D channel, I'm Kaylee Duffy, and this has been your Engineering Newswire.